Assalamu alaikum everyone and good afternoon. This is Bakhtavar Nawal, Co-Head Management at IEEE and TRAC, and I welcome you all to this collaborative event of IEEE with TRAC, IEEE, IEEE Assess on the topic The Basic Art of Machine Learning. Machine learning, being one of the emerging streams these days, has gained much significance in the field of technology. In this webinar, you will be enlightened with all the basics of ML. For this, we are having Ms. Ramsha with us, who is machine learning engineer working in the domain of conversational AI and knowledge logistics at Boomtown SA. She is the WTM Ambassador, scholar, and lead at Google Developers Group Lahore and Global UGRAD Alumnus from UIW Texas. Thank you so much, ma'am, for being here with us.
Guys, happy Sunday. Glad to be here.
Before I hand over the mic, I would request you to please keep yourself muted throughout the session. All of your queries will be entertained at the end. Now, I once again welcome you all, and now I would request ma'am to please initiate the session. Over to you, ma'am.
All right. Thank you, Tavar. All right. I hope my screen is visible. Cool. I'm just going to assume that it is. Hey, guys. Thank you for joining on a weekend. I know it's hard. It's hard for me too. Okay, let's talk about the session, which is the basic art of machine learning. Just to give you an intro of what this session is about. So today's session is an introductory course for anyone who's trying to get into machine learning, whether you are a web or Android developer, or maybe just a student in your junior year. This session might be good for you to get an overview of the different terms that are very commonly used in machine learning, but are usually explained with like mathematical formulas and code. And so this is more student level stuff. And you'd hopefully be able to understand this without having to implement algorithms from scratch. So it's my take on machine learning and how it resembles human learning. My introduction, well, Bakhtar already did most of that, but I'll do it again. I'm Ramsha Siddiqui. I work as a machine learning engineer at Boomtown. Most of my experience is in conversational AI and dialogue systems. I graduated from university almost 2 years ago. 2 years ago, or it was 2019, so yeah, 2 years ago. Yeah, seems like a really long time ago, but yeah, so getting into this field and becoming a machine learning engineer after doing your bachelor's in computer science is actually not that hard, and you can get a job abroad, like in San Francisco, pretty much the same way that I did. So yeah, let's get into the session and how you can get into it. All right, the first question that you may want to ask is the difference between artificial intelligence and machine learning, because a lot of the time people use these terms interchangeably. Well, machine learning is an application of artificial intelligence, which allows machines to learn and improve from experience. Here, experience could be learning from themselves or from data without being explicitly programmed to do so, like you would in a general rule-based system of if and else. So it's known to almost solve like any problem in the world, and today people are actually solving it or using it to like solve almost every problem of the world. So it's pretty important in today's era of technology. To get an understanding of how machines learn, my take on this is that let's look at how humans learn and go from there. Like, how do humans learn any specific concept or knowledge? So the typical life of a student starts with you enrolling in a course or picking up a book or even a YouTube video, and you generally need the help of a tutor or a teacher to get you those early on concepts in your mind, or the theoretical knowledge that you need for your desired subject. The second step is where you extract new concepts. So you see, reading a book alone or just watching a video won't help you out a lot unless you deduce your own concepts from that information. So usually what I do is I draw flow diagrams or make notes in my diary that help me understand and analyze the information that's coming to me from these different sources in my own way. The third stage is where you practice these concepts. So if you're in a math class, you would implement equations you're trying to solve with some random examples. Or if you're a programmer, you try to write an algorithm, or maybe just debug or run an algorithm yourself, or even just solve a practice quiz. So all of these steps further help you understand and revise concepts that you've just learned in your head. And then the final stage, which is something that every student has to go through, sadly, is exams. So in order to be sure that you've completely learned a concept, you have to sit through tests. So it could be like essays or something theoretical like MCQs. And at the end of the test, you will have a grader or examiner who will grade you based on your output or answers. And then you can compare your performance against others to see where you stand. After that self-evaluation, you would either repeat the steps above, gather more knowledge, extract more concepts, refine your knowledge, and then practice some more, and this cycle continues. So an example of this, we can take chess. So step one, learn about the pieces and the moves, maybe buy a chessboard. Second step would be to learn how the movement of one piece influences the movement of the others, and how many moves are left after a certain move, or how many moves you need to beat your opponent in different tactics. How to avoid dying, maybe, or yeah. The third step would be to sit with a friend and now practice this, right? Whatever you've learned about the moves, you want to practice it, so you want to try that a few times, maybe lose from your friend before you go into step 4, which would be to test yourself out as a pro. Even if you're not a pro, you may enter like the big leagues and see where you stand. So yeah, using these 4 steps, you'd hopefully learn how to play chess. Well, that's great. We now know how do humans learn. Now let's relate these 4 steps with how machines learn. So again, step 1 was to gather knowledge or training data. Now in machine learning, training data is the same form of knowledge that you would give to a human to learn something. Similarly for machines, let's say you want a machine to classify an image as a cat or a dog. You first need to feed it with a bunch of images that are labeled as cats or dogs. Other sources of data could be texts, messages, or audios, etc. And for gathering or creating this data, you need people like data annotators or data curators that will specifically create this data, like take an image and label it as a cat or a dog, that you can then feed to your model, or your model can utilize. So this is also usually the first step of any machine learning pipeline in a professional practice as well. Step 2, if you remember, was to extract concepts from the knowledge that you've just learned. So just like humans extract concepts from knowledge, machines can also refine knowledge that they gain as input, which is a process known as data preprocessing. They use this process to convert raw information into useful features that they can then use to learn the output that the machine is being trained on to predict. So for example, if you have an input that's an image, you want to break down that image into the numerical representations of each pixel, like the pixel intensity or the color. And similarly, if you have an input of text, you want to break it down into different words and then have IDs that represent each word, or the numerical representation of each word, which is normally known as vectors. So yeah, this step is pretty important, and you may ask why. The answer to that is it's an expression that we use in machine learning called garbage in, garbage out. So it means that if you feed garbage data, which is like raw or uncleaned, unprocessed data to a machine learning model, you are bound to produce a garbage output or performance as a result. Whereas if you process it into a quality format or quality data, then you will get a quality model out of it. So that's pretty neat, right? At this point, I've mentioned that machine learning algorithms, the term machine learning algorithms or models a few times, and I think it's about time that I explain that. So a machine learning model or algorithm can be thought of as a mathematical derivation containing variables that can be derived or learned from your training data. So scientists have often compared models with human brains. You can think of our brains as children as an enormous amount of random variables that need to be filled or initialized with values or data that we learn from our surroundings in order to perform the daily tasks of life. So that's pretty much the same that what machine learning models do. Every machine learning algorithm is meant to learn a task and is initialized with variables meant to learn that task. So the values that these variables can take are from your training data, and these values you then save, attached with your variables at the end so that you can use them for predictions later on. So as an example, I have this equation here, which is not a machine learning formula, but just an example. Here you can see that if you want the value of x, which is your output, you need to learn the values of a, b, and c, which are the variables in your formula. This is pretty much how any machine learning algorithm is built. You have some output you're looking for, and you want to learn the variables that represent that output. So going to step 3, after gaining knowledge and extracting knowledge, you now want to practice it. So practicing it means that you want to absorb it and just see how that data is going to help you do predictions in the future, which is step 4. So this practice this practice step is where in machine learning models you would have the step of model selection or construction. So after data collection and pre-processing, you want to select the model that will learn this task for you. Selecting the right kind of model for your machine learning problem is also important because feature learning or data understanding is an internal process for machines, and certain types of problems are more well suited for certain types of algorithms. So let's look at the 2 most important types of machine learning algorithms today. The first one is called supervised learning. This is when the expected outputs of your task are defined by your data annotators. So if you're trying to classify images, again, those images would be labeled as cats or dogs. Or if you're trying to predict the price of a house, given its location, area, or features, you would have the price of the house, in your previous training data from your history already labeled by your annotator. We're going to see some examples of this supervised learning just to convey this concept a bit more. The first one is something that you use probably every day on Snapchat, facial recognition. So data annotators have labeled images where areas that define a human face or eyes or head pose, these images were labeled by their circumference by a data annotator that when fed to a model was able to learn exactly where in an image a human face lies, right? So the most common type of model that's used for this task is called a convolutional neural network, which you can search. Just a general idea of what it is. It has a filter or window that it drags across an image looking for specific features like eyes, nose, lips. And then once it finds those features, it provides a certain score of how certain it is that this feature was identified in an image. Using these features, we can then predict whether or not this was a human face. Pretty cool, right? I hope. All right, another example is speech recognition, which I hope you're also familiar with using Google or Siri, where your input is an audio and your output is text. One common type of models that are used for speech recognition are called sequence-to-sequence models, as in a sequence of audio is going in as input and a sequence of words or text is coming out as output. So models like this, they parse sequences of an audio in concatenation over time to predict the letter at a certain audio frame or groups of letters at a certain audio frame or like words and then groups of words and text altogether. So lots of research is still going on in this area, but these types of models are pretty common for this kind of task. Another example that's been common in last year and maybe this year as well, not sure, is COVID projection. That is predicting the number of COVID cases that might occur every other day or month. So this is a problem of predicting a real number or a continuous value, right? Those previous problems were more of predicting labels. This one is of predicting a certain number. So for tasks like this, you have time series forecasting algorithms. They take in as input the number of COVID cases, like say in the past 2 months, and then try to predict the number of COVID cases in the next month. Then they slide the window a bit and do the same over and over. And that's how we have our training data. And using this and observing the ups and downs in previous data, the model is able to predict what might happen in the future. So I think this is one of the coolest applications of machine learning because people use this to predict stock prices and yeah, even in cryptocurrency, whether or not stock will go up or down. So some of these models are trained so well that they actually work pretty good as a real application in the real world. Just a note that I wanted to make here in terms of the problems that we just saw, like image or text classification. A lot of research has been done on these problems for many years now. And so there are many architectures that are available today that are specifically specialized for these tasks, like image classification or text recognition, things like that, which makes this step 3, which is model selection, much easier to do. So if you're going to start working on these problems, I suggest that you always start with doing research on an already available data set online and a pre-built model online that you can jump in with rather than starting from scratch. Yeah, just a bit of advice. All right, the second type of machine learning is unsupervised learning, which is obviously different from supervised learning. This is where your model's expected outputs are not defined by your annotators, and all you have is just a bunch of unlabeled data, or you can call it garbage data. In this case, your input data just needs to be clustered or segmented into different topics, even though you have no idea what those topics are or even how many topics might exist. So an example of this is topic modeling. It's the task of training a model to learn the topics of a document based on the correlation of words used inside it. And so it's only based on the fact that you've never actually read the document or labeled what topics lie in this, but all you want is just to group a bunch of news articles or a bunch of websites into one category that you can then reference and see how they relate with each other. So here you can see that in this image, someone has tried to group topics of the Star Wars discussions on Reddit into 3 categories of red, green, and blue, which I'd say it's pretty fun to do. One last note that I want to make here in terms of selecting which type of machine learning problem you're dealing with, I'd ask you to be wise with your with your just understanding of your problem. If you already have outputs in mind, like cats versus dogs, or if you want to translate a piece of text, that means that you already have an output that's defined. In this case, you want to go for supervised machine learning, and you want to label your data for the output you're looking for. But if you don't even know what output you're looking for, if you're just trying to research or group your data in a way, such as in this example, you don't know how many clusters of animals exist in the ecosystem. So in these cases, you want to go for unsupervised learning. Woo. Okay, so we spent a lot of time on step 3, which was model selection. Now on to training the model, which is actually making it learn from the data, right? So a couple of things that you want to do before training. Number 1 is to split your data into 2 halves, and they don't have to be equal halves. One half you want to use for training the model, and then the other half you want to use for testing it later on. You want to think about how many times you want the model to revise the training data, as in, keep on seeing the training data. That's called the number of epochs. And the more number of epochs you have, the longer it will take for your model to train. And then the third thing you want to look for is the possible set of initial variable values, or number of variables, number of layers, or the right kind of algorithm, or its combinations that you want to use in your model in order to learn a certain task or a certain data set. The more time you'll spend on these 3 tasks, there are different kinds of results you'll get from your training, and then you can select the best one. So just to give you an example of what a training might look like, here's this image where you can see the equation W1 times X1 plus W2 times X2 plus W3 times X3 equals Y. Now this is a linear combination, and machine learning algorithms aren't exactly like this, but there are certain neurons that actually have this formula. Here you can see that X's, like X1, X2, X3, these are your input values, like your input features. and y is the label that you're trying to predict. And these weights, like these variables, W1, W2, W3, these are the 3 variables that you want to learn from your training data. So for every training example, you will learn a different value of W1, W2, W3. And yeah, you want to learn like an average value of these 3 variables that will work pretty much, closely for your output variable Y as you train more and more. So yeah, you can see this image where there's a boundary that's keeps on changing as more and more data comes in, and that's pretty much what's happening in your model training, is that for all of the training data that your model is seeing, it keeps on adjusting the values of W1, W2, W3 so that its multiplication with the input gives you the value Y that you're looking for. That's the easiest way that I could explain model training. If you want to get into it more, you'd have to look into machine learning algorithms and their formulas and how you can use them. All right, so the final step is model testing, which is school exams. So after training, you want to see your model predictions and then compare the values from your model with the actual values and see how many you got correct or incorrect. So like in this image, you can see that the values in yellow, water by water, forest by forest, and urban by urban, these are the values that your model got correct, and then the rest are those that it got incorrect. So overall, you see that the performance of your model is pretty good, like it's 95. So yeah, your model is doing good, right? Just a little bit side note on task performance or model performance that I want to mention. As humans, you know that sometimes you do your best at a subject or a class and somehow you still underachieve. Or you don't even take half the classes and somehow you're just acing that semester. So we want to discuss or at least address these 2 issues for machine learning models as well. The first one is, what are the reasons as to why your model may not get good results despite putting in a lot of effort? Well, the number one is unseen test data. You know how your teachers sometimes teach you like 2 + 2 = 4, and then in the exams they will ask you like the distance between the earth and the sun. Yeah, some people do that with their machine learning models as well, and it's generally advised not to do that. Only test your model on data it has previously seen. If your test data is different from your training data, add examples of your test data to your training data. Another problem is that maybe your model was trained on too little training data, or maybe the features, the input features, they were actually garbage, or they were not refined enough for your model to learn anything. So instead of changing your model, you need to change your input data. And then the third step is maybe the model architecture that you're using is not built for the task that you're using it for. So maybe change the architecture or maybe change some of the parameters. The other side of it is like overachieving, perform better than expected. Well, first, it could be that it gets lucky in certain iterations and it doesn't get lucky in others. The second is that maybe your model was already trained on a task that was larger than this one, but kind of encapsulated this task, and it still remembers it. So it's really helping you perform well on this task, even though you didn't actually train it a lot. This practice is actually adopted in the professional space with a term called pre-training, and it's causing most of the progress or research in a lot of machine learning algorithms today than it was before. Maybe check out GPT, which is called general purpose transformers, or just GPT-3 in general. Maybe you've seen it on the internet, and you'll see that it's a very big model that's trained on literally everything on the internet. And now people are using it for like smaller tasks, and it's performing very well. So it could be one of the reasons. Finally, a note on model predictions. Now that your model is ready, you've gathered all your data, you've refined it, you've trained your model, and you've tested it. It's working pretty fine. A note about how to present your model predictions to your users. Now, in order to trust that your model is working correctly, it's always a good idea to provide additional information or explainability with your model's results in your outputs, like we see here in Netflix. You see that there's this text in green that says 96% match. This is the confidence score of the model that Netflix shows you in order to build, a confidence in your in the model that Netflix is using. Another text that you see here in bold is on the top saying more like this. This is Netflix's way of telling you that it's using the current movie that you've selected as a feature for predicting these additional recommendations. So it's also a good idea to tell your users what features you're using to give certain predictions for your machine learning models. And this builds some faith or belief between your users and your applications or websites. Yeah, it just helps bridge the gap between the trust and yeah, makes users happy with machine learning models. All right, that's pretty much it from my side. If we had time, we would go through this little model building exercise, which is all through a user interface and not with any mathematical formulas. But I think we've run out of time. Yeah. So yeah, I'll just leave this link here. It's called teachablemachine.withgoogle.com. And yeah, you can go here and train your own model in literally 5 minutes for a bunch of image classification or text classification tasks. And it's pretty fun to do that. All right, thank you. If you have any questions, feel free to read them in the chat. Thanks.
Thank you so much, ma'am, for such an insightful session. We'll be moving towards our Q&A. So guys, if you have any question, you can raise your hand or else you can type in the chat box too.
Oh, I'm actually not able to access the chat. It says it's only available to team members. There might be something I want to fix.
Ma'am, there is a question from an attendee. He's asking, can you explain the difference between supervised and unsupervised learning?
Yes, supervised learning is when you want to supervise the task that you want your model to perform. It's ML experts' way of saying that your data needs to have, or your task at hand needs to have a defined output. So let's say if you're doing an image classification task where you want the model to predict whether or not there's a cat in the image, then you'd have to label a bunch of images with whether or not a cat was present. So if a cat was present, label it as 1, and if it wasn't, label it as 0. This would be an example of supervised learning. Other examples are speech-to-text classification, like you want audio as input and the right text as output, or maybe you want to predict some number in some time series classification. In unsupervised learning, you don't have an output defined. You just want your data clustered into different categories. For example, you have a bunch of websites on Google, and you want these websites to just be clustered or categorized together so that then you can look at properties inside each cluster and have something to say about them. That would be an example of unsupervised learning where you just have unlabeled data, like loads of it, and you don't even know what the output is or how many output labels there are. You just want it clustered and you want the model to tell you like, hey, these things look like they're closer together or they're of the same shape or have the same features. So maybe they all lie in one category. And then this usually helps people do some analysis before jumping into a supervised problem, or it's just good for research purposes.
Thank you, ma'am. We are having another question. What are the basics we should start from for learning machine learning, like which programming languages and where to go to from there?
Cool. I would recommend Python because even if you're not a programmer, it's easy to learn Python. It doesn't have a lot of syntax. Also, in most professional spaces, Python is the preferred language. Some people use R as well, but I would say it's a bit more advanced. So yeah, my recommendation is jump in with Python. Second, I would recommend there's this course called Intro to Machine Learning by Andrew Ng on Coursera. I think it takes about 3 months or maybe 4 months to finish, but it's a really good course. And yeah, if you're serious about learning it, definitely start there.
Okay, and I guess someone is asking a question. Someone please unmute your mic.
Okay, ma'am, I have a question related to machine learning that you have shown us a basic equation that we can solve through machine learning. We can also solve the different theorems related to physics in machine learning. Like, is it able, like, we can train the system to solve those methods as well or not?
Yeah, it's usual if you talk about like machine learning models being used in areas of physics. I can tell you that at NASA, they've built robots that are self-improving or self-learning in a way that they learn how to repair themselves. They learn how to walk on a surface on their own. Yeah, they learn a bunch of stuff in that way. So it is definitely used in a lot of areas of physics. It's also applied there and in other areas of engineering as well. Definitely check out NASA because they're pretty thick on using machine learning these days. All right, anything else?
I guess, ma'am, there are no more questions. So let's wrap up this webinar as we are short of time too. So thank you so much, first of all, for being here with us for such an amazing session. The students have surely gained a lot from your knowledge. And lastly, I would thank the audience too for being here with us. It's you, audience, that makes an event successful and engaging at the same time. So yeah, best of luck for your future endeavors, and thank you so much, ma'am, again. Is there something you want to say before we conclude?
No, yeah. If you're interested in machine learning, I hope it helps. Yeah, definitely go into this field. It's growing a lot these days. I think even in other areas or other professions in computer science, you would find machine learning just slowly creeping in to jobs that you do. So yeah, maybe learning it at this stage is probably a good idea. But yeah, up to you. And feel free to reach out to me on the email that I mentioned or on LinkedIn. And yeah, happy to help in any way.
Okay, thank you so much, ma'am. So we're concluding this webinar. Hope you guys have learned a lot throughout the session. So best of luck and take care, all of you. Allah Hafiz.
Thank you.